Hello everyone, I am Grace Lee, and this is Dominic Mela. We'll be your teacher for today. I hope we have fruitful and fun lessons.
Today we will first recall our last session. Then we will interpret the Venn diagram in terms of sets and subsets, and solve the union and intersection of sets using the Venn diagram. Let's review our topic yesterday. Do you still remember what we learned? We learned about the set, subset, universal set, null set, the union of sets, and the intersection of sets. So let's check for comprehension. I have here a backpack, notebooks, books, an umbrella, and a set of pencils inside a pencil case. Since I have these items with me, let's consider the backpack as the universal set. If I put the notebooks inside the first backpack compartment, books on the second, a pencil case, and an umbrella in the third compartment, how many sets do we have? Yes, James, you're right. Since we have 3 bag compartments and a pencil case, then the answer will be 4 sets. Now, how can we state the sets as well defined? Correct. As long as it is possible to determine whether an object belongs to a given set or not, it is a well-defined set. For this backpack, we can say that the first compartment is the set of notebooks. How about the third compartment? Since I put 2 items, a pencil case and an umbrella, will there be a subset? Yes, James. Since the pencil case contains several pencils, it is a subset of the third compartment. If I remove the items inside the third compartment, then what do you call the set with no elements inside? Good job, Pinky, you're right. It is called a null set. Now that all the items are inside of my backpack, suppose we need to get a math notebook and a math book from the first and second compartment. Since we want to identify and get the math-related items in both sets, then we consider this example as the intersection of 2 sets. Suppose we want to remove all the items from the compartment 1 and 2 and place them into a new backpack in the same compartment. Then we can consider this scenario as... Yes, Sophia, you're right. That is considered as an example of union of sets. Since we have recalled, I guess we are ready to call Teacher Grace for a new topic today.
Hi guys, today I brought 3 shopping bags. Aren't you wondering what's inside? It's Uno cards. For today, we will use these cards to construct a Venn diagram and learn about the operation of sets. So, here goes the rules. As you see on the board, there are 3 big circles overlapped partially together. This is what we call a Venn diagram. The reason circled by red, blue, and yellow lines is for the respective Uno cards with the same colors. Hence, your task for today is to pick a card in the shopping bag. Then, you should paste the card in the respective region of the diagram. Those cards will be the elements of the particular sets. Starting from Tom, can you pick a card in a red shopping bag and paste it on the board in the respective region of the Venn diagram? Good job, Tom! You're right! Now, let's try Pinky. Great! How about you, Mia? Excellent! Likewise, James and Sophia, can you try? Both of you did well. However, we can see that 2 cards have the same number, which is 8. Will there be a way to put them in the same reason? Can somebody try? You're right, Sophia! We can put them together since that reason is for red and blue cards that have the same numbers. Let's continue. Now, let's try to pick one last card. Great! But this time, we see 3 cards with the same number. How can we put those in the same reason? Excellent! Good job, everyone!
Since the last meeting, we have discussed the definition of sets and subsets. Starting from Tom, how many sets can you interpret based on our Venn diagram? Correct. The answer is 3 sets. So, we got elements of set A, B, and C as you can see on the board. The Uno cards represent the elements of the sets. Mia, Pinky, and James, can you list down on the board the elements of each set? The 3 of you got the correct answer. For set A, the elements are 3, 8, 5, 9. For set B, the elements are 7, 8, 9. Lastly, for set C, the elements are 6, 2, 9. Seems like we can proceed to the next topic to teach you how to do set operations using the Venn diagram.
Using this information, let's try to solve for the union and intersection of sets. When we want to get a union of sets, we're looking for all the elements in the set sets. Meantime, when we want to get an intersection of sets, we're looking for the same elements that are present in the set sets. For example, the union of set A and B will contain all the elements in the shaded region, since we want all elements. Hence, the answer will be 3, 8, 5, 9, and 7. But if we want the intersection of set A and B, then we only need the elements inside the overlap region. Hence, the answer will be 8 and 9 only. So this time, I would like to ask you, what do you think is the union of set A, B, and C? How about the intersection of those sets? You're right! Perfect! Before we end our class, we would like all of you to check the description box below, where you can access the Google Drive link of our last formative activity. If you download the file, you will see true or false and find the correct reason questions.
During true or false activity, click T if the answer is true, otherwise click F.
During Find Me a Correct Reason activity, click the part of the reason that is correct. Sometimes it is possible to have more than one reason as an answer.
Once you finish, you will see your score. Screenshot your score and post it in Padlet using a given link.
So, how was the class today? Did you enjoy it? I hope you learned something today. And see you next time!